getting close to the end of the semester. We still have several topics that I want to address before the end of the semester. I want to make sure that everyone at least has a basic introduction to scaffolds and aerial lifts, which will be Unit 8. We're also going to spend some time talking about slips, trips, and falls in the workplace, or I should say slips and trips. We've already talked about falls from elevation, but slips and trips also a big issue in the workplace that needs to be addressed. And we're also going to fit in a unit on ladders. A lot of injuries involve ladders that are misused, used improperly. But again, this unit, scaffolds and aerial lifts, it's going to be a very basic introduction. I could do an entire week-long class just on scaffolds. This is also one of those topics that really should have a hands-on component. It's kind of ridiculous to do this online, to be honest, in my opinion. What we should be doing is setting up a scaffold, building a scaffold, breaking one down, learning about a scaffold by putting our hands on the scaffold. Same thing with aerial lifts. It's hard to do that online. Haven't figured that out yet. Again, this is my first go around for doing this class online, but this is certainly one of those topics that should not be an online topic. But it is what it is. I didn't make the choice to do this online. I was told to do it online. So again, basic introduction to scaffolds. This is really directed more at you guys who have never had any experience with scaffolds. If you have had some experience with scaffolds, you're probably going to find this boring. If you've had any experience with aerial lifts, same thing. I mean, I'm sure there will be some regulations that I mentioned that maybe you hadn't heard of, or maybe you had forgotten. So that there's value for everyone, but it's really going to be most valuable to those who have never worked around scaffolds. And if you've never been around scaffolds and don't have a clue what we're talking about, this is a scaffold, what we see erected around this building. You'll often see scaffolds erected during construction or also during maintenance. This is a maintenance operation or a renovation job. They put scaffolding all the way around the building. It could be tuck pointing brick. It could be paint work. It could be cleaning. They could just be cleaning the exterior facade of the building. A lot of different possible reasons for setting up a scaffold on a multi-level building like this. Another thing I should say about scaffolds and aerial lifts, not just construction. A lot of industries, I would say all industries for the most part, will use scaffolds at some point in time. Aerial lifts, same thing. If you're in manufacturing, there will be operations going on within the manufacturing facility that involves scaffolding. There will be operations going on within manufacturing that involve aerial lifts. So this is a topic that does apply to all industries. Now the regulations that I'm going to be referring to, those are from the construction industry regulations. But again, at the end of the day, it's not about the regulations. It is about using these tools safely so that nobody gets injured. And scaffolds and aerial lifts, they are tools, and they are safe tools if used properly. But if they're used improperly, then that's when we have the injuries and fatalities occur. Scaffolds and aerial lifts every year are associated with multiple fatalities in the United States. So let's go ahead and look at a definition of scaffold. Again, very basic stuff, I get it. But a scaffold is a temporary work platform allowing workers to access elevated work areas. Now, there is a guide book from OSHA that I provided to you on Blackboard. This is the cover for that guide, Scaffold Use in the Construction Industry. And the tips, the ideas, the recommendations, the regulations in this guidebook are applicable in every workplace if we're trying to achieve a safe workplace. There are several specific types of scaffolds that we're going to talk about. Supported, suspended, rolling mobile, horse scaffolds, which I hate, ladder jack scaffolds, which I also hate, and pump jack scaffolds. These are the basic components of a scaffold system. We have the scaffold frame that supports the work platform or the deck. This work platform, this is where the workers will be standing. Again, the frame supports the platform of the deck, a guardrail system that provides fall protection, and a cross brace. The cross bracing, and different scaffolds are going to have different designs for the cross bracing, but the cross bracing and other structural elements, it helps maintain the structural integrity of the scaffold. If you didn't have these cross braces in place, this thing would fold right up. You got to have that bracing in place to keep it stable, to keep it secure. And maybe the most important part of a scaffold that often gets overlooked is the base. The base plates need to be in place. They need to be sitting on mud sills in most instances, and the mud sills need to be on solid ground. The ground that supports the scaffold is part of the scaffold, and if that ground is soft, if that ground doesn't have adequate compressive strength, then that weakens the scaffold. So the ground is an important part of the scaffold system. Again, different scaffold types that we're going to talk about may have some different elements that aren't illustrated here, but these are the basic components of a scaffold. Pretty simple structure, but very important in a lot of different industries for getting work done. Now, one thing I'll mention here, you only have 3 sides to your guardrail. This is okay, assuming that this side of the scaffold is placed up against the side of a building. If placed up against the side of a building, then the building itself provides the 4th guardrail. Now, if this is not placed up against another structure, then you would need to have this entire work platform encircled with guardrails. But we will talk more about fall protection on scaffolding as we move along. Some general requirements from 1926-451. These are the OSHA construction guidelines or regulations for scaffolding. The scaffold needs to be designed by a qualified person. That's the OSHA regulation. I would argue that the best practice is it's designed and approved by an engineer, following temporary structures and construction device guidelines, like we talked about earlier in the semester. And this is best practice. OSHA doesn't require an engineer except in certain circumstances. But best practice, have an engineer give his or her stamp of approval on your scaffolding system. Now, a qualified person, not an engineer, a qualified person, though, does have training, experience, knowledge. They know what they're doing, and they know how to do it right. And there's no disrespect to qualified persons when I say you should have an engineer involved. Having an engineer involved protects the company from OSHA citations and also from any liability that may be incurred if there's an accident. If you show that there's an engineer signed off on it, that is a very valuable legal defense if there are any problems with your scaffolding system. And if you just have Joe with 15 years experience who's very qualified to design it, but he's not an engineer, that doesn't carry as much weight as a legal defense. It may meet the OSHA requirements, but it's not going to carry as much weight. The scaffold must support 4 times its intended load. So if you're going to put 1,000 pounds on the scaffold, it must be designed to support 4 times the intended load. And that's where the engineer comes in. The engineer can run those numbers, can do the calculations pretty quickly, and ensure that our design will support 4 times the intended load. Joe, the experienced foreman, he can build a good strong scaffold, but he may not be good with the math that supports this idea that proves that it supports 4 times the intended load. The decking or the platform must be what's referred to as scaffold grade. Now this, if you're using dimensional lumber, 2x6s, 2x8s, 2x10s for your scaffold decking, it needs to be scaffold grade or the equivalent of scaffold grade. There are a lot of different decking types that can be used. You can use dimensional lumber, you can use manufactured decking systems or work platforms, but if you're using lumber, it's got to be scaffold grade. And you can buy lumber that has a stamped scaffold grade, but normally any good quality dimensional lumber without knots and checking and warping is going to be sufficient. But now you will run into some companies, I need to mention this before I move on. Some companies require their scaffolding to only be constructed with lumber that has the scaffold grade stamp on it. The deck, if you're using 2x8s, 2x10s, if you're using planking, it has to be fully decked with gaps not exceeding 1 inch. Now, a lot of these points, I'm going to have pictures. Most of our discussion of scaffolding will involve looking at pictures of scaffolding and identifying what's right or wrong about scaffolding. And I will point out most of these issues again when we get to those pictures. Your deck must be at least 18 inches wide with a couple of exceptions. Ladder jack scaffolds can be narrower. Pump jack scaffolds can be narrower. You must have, according to OSHA, fall protection at 10 feet. You need fall protection anytime there's a chance a worker could fall and get hurt. But this is the OSHA requirement. If it's a scaffold, you don't have to have fall protection until you get to a height of 10 feet. Also, if you're using guardrails for your scaffold, you need to ensure that the guardrails fully enclose the work platform. One deficiency that's commonly seen is that they will only have guardrail on one side. They won't have the ends protected. Get a sip of water there. I'm getting kind of dry. Your scaffold, once it's set up, it needs to be inspected daily by a competent person. OSHA definition of a competent person is a qualified person who has the authority to take corrective action. The authority given by the employer to take corrective action. The competent person can shut the job down. They can put a do not use tag on the scaffold and the scaffold can't be used. The authority is really what makes someone a competent person, not their qualifications. A qualified person, like we have over here, is not necessarily a competent person. But a competent person, generally speaking, is going to be a qualified person with authority or with the authority. But you can also run into circumstances where the competent person is not the qualified person. They're working with a qualified person to determine if the scaffold is designed properly, if it's adequate for daily use, and so on. But this inspection is an important part of using scaffolding. It needs to be inspected daily. There's a whole system of tagging and inspection documentation that companies will normally use. They'll put a tag on the system indicating that it's safe to use, and on that tag there will be space for the daily inspections. If the scaffolding is not suitable for use, it will be tagged out using a similar tag. Also, another problem that you'll see a lot of times with scaffolding, workers don't have a safe way of getting up to the work platform. It's required that employers provide a safe way to get on the work platform. We'll look at a couple of pictures where workers are climbing the scaffold frames. You can't do that. The only time you can use a scaffold frame for climbing is if that frame is specifically designed and rated as a ladder. And some scaffolds are, but many aren't. Do not put more weight on the scaffold than it's designed to support. Do not overload. anyone that's involved with scaffolding, they put up the scaffold, they tear down the scaffold, they're working on a scaffold, they need to have training on the different aspects of scaffold safety. And I mentioned this specific regulation here. This is the specific regulation that states this training requirement. Another thing to watch out for: no cantilevered work platforms. Or if there are cantilevered work platforms, the cantilevering must meet the OSHA regulations on cantilevering. And some of you are sitting out there, what the hell is he talking about cantilevering? Well, let's talk about what we mean by cantilevering. If we're talking about a scaffold, and cantilevering, we're talking about the portion of the platform that extends beyond the scaffold supports. Again, you have the scaffold frame that supports the deck. Going back to that earlier picture that I showed, you have the scaffold frame that supports the deck. That frame, those are the supports. Your deck, if it extends beyond those supports, that's a cantilever deck, which is not necessarily wrong, but it has to be done correctly, or it can cause some safety issues. Let's look at a couple of different scenarios, and again, this is based upon the OSHA regulations. If our scaffold platform, and this is a plan view, we're looking at it from the top. These are the supports right here, and this is our scaffold deck. If our scaffold deck is resting on the supports, or there's less than 6 inches of cantilever, there must be a mechanism that positively connects the deck to the platform. And that mechanism for that positive connection could be hooks, it could be nailed down, it could be other connectors. And the reason for this is that you don't want that platform to slip off the support. If it's not positively connected, or the cantilever is less than 6 inches, that deck could slip off the supports, and you don't want that to happen with workers up on the platform. That could make for a really bad day for everybody on that project at that facility. If you don't have a positive connection, if it's not nailed down, if it's not hooked down, if there aren't other connectors, the platform must extend at least 6 inches beyond the support. That's what we have here. And there's our support. We have at least 6 inches. But we can cantilever too far. And if we cantilever too far, that's not good either. If we're using cantilevering, the cantilevered section cannot extend more than 12 inches beyond the support if the scaffold platform is 10 feet or less. I know this is hard to get your head wrapped around. I'm probably not doing the greatest job of explaining it. But if our scaffold platform is 10 feet or less, the cantilever cannot be more than 12 inches. If the scaffold platform is greater than 10 feet, it can't be more than 18 inches. So there's two main safety issues that we're addressing when we talk about the cantilevering of the work platform. The first we've already mentioned. We don't want the platform to slip off the supports. The other issue, we don't want the platform to become a teeter-totter. Let's say this extends out to 24 inches beyond the support. It extends out to 24 inches beyond this support. Now you have a worker come moseying down here, not paying attention to what he's doing. He steps in this area, then the whole platform could flip up, sending him to the ground with all of his tools and materials on top of him, possibly. So that's another reason why we have to pay attention to the cantilevering, because of the potential for instability and this teeter-totter thing happening. Again, we also don't want the deck to slip off our supports. And we'll address this again as we look at some pictures in our hazard recognition section of this unit. Another issue to pay attention to: the distance from the wall or other structure that we're working against. Let's assume that this big gray box here is the wall or the building that we're working against, or other structure. If we're in a refinery, it could be a catalytic cracking unit or something like that. But we have this structure that we're working up against. Generally speaking, the gap here cannot be greater than 14 inches. No more than 14 inches. There are exceptions. If you're doing plastering work, it's allowed for this gap to be no more than 18 inches. You can go out to 18 inches if it's a plastering job. The problem with a gap that's too large, there's an opening that workers could step into. If the gap is greater than 14 inches, a guardrail must be installed around all four sides, or other fall protection equipment must be in use, because that is the issue. Prevent a large opening the worker could step into. Let's take a closer look at the different types of scaffolds. What we have here in these pictures are both examples of supported scaffolds. Supported, they're on the ground. They have a scaffold frame that supports the work decks. And this particular scaffold system here, this supported scaffold, has multiple levels of work platform. You'll see that in some large structures, some multi-level structures. This one over here, just a single level of work platform. As I mentioned previously, with a supported scaffold, the surface that the scaffold sits on must support the weight of the scaffold and all of the weight that's placed on the scaffold without sinking. Generally speaking, base plates and mud sills are required to prevent the scaffold from sinking into the soil that it's sitting on. And a lot of it depends on the soil type, the soil conditions. Also, it's not a bad idea to have an engineer involved in doing your soil classification to make sure that the engineer can tell us what type of soil we have, what type of support system we need for our scaffold. Another issue with supported scaffolds: it must be tied off to the structure that it's up against when the height of the scaffold is 4 times the width of the scaffold. So if the scaffold deck is 4 feet wide, once we get to that height of 16 feet, we would have to start tying it off to the structure. Then that would be the first tie off point at 16 feet. Then we tie it off every 20 feet as we continue upward with our scaffold. If our scaffold is 3 feet wide, we would tie it off at 12 feet and then every 20 feet. Being tied off to that structure in some way is very important when scaffolds get really tall. And scaffolds, I really haven't shown you any pictures of scaffolds that go way up in the air, but they can go hundreds of feet up into the air. And our scaffold must be designed to support 4 times the intended load, as we mentioned previously. Everything has to be plumb and level. Plumb meaning all of your vertical members are straight up and down. They're not leaning one way or the other. Level means level. Plumb and level. And this goes back to your ground and your supporting surface and your base plates and your mud sill and your leveling jacks. I'll talk about it more, but many scaffolding systems will include what we call leveling jacks that allow you to tweak and fine-tune our leveling so we're dead on level with our structure. Another thing I should mention about this type of scaffold, this type of scaffold might be set up and remain set up in position for several months. And it's important that it be built right if it's going to be up for several months, if it's going to be sitting on the ground for several months. Another issue with the soil that I haven't mentioned, the soil needs to be well drained. You don't want a mud hole, or you don't want your scaffold sitting in a mud hole or a lake that's at the base of your scaffold. Again, as we said before, inspected by a competent person daily. Additional information, this information here and additional information, OSHA Regulations 1926 451C. This is a specific type of supported scaffold with a tube and coupler design. The tube and coupler design refers to how all the connections are made between the vertical and the horizontal members, the vertical frame and the cross bracing and so on. But I like this picture because it shows the different components, and it has the different components labeled. This type of scaffold, and I don't agree with this at all, this is a ridiculous OSHA allowance. OSHA allows this type of scaffold to go up to a height of 125 feet without an engineer involved. That's 125 feet without an engineer involved. That's kind of crazy. Best practice, have an engineer involved. And engineers aren't the saviors of the world. You're probably starting to think I believe that. That's not the case, but it's a legal liability issue. And engineers also have the ability to do calculations and show that the scaffold is properly designed. And they have knowledge from their experience, from their classroom education. I'd say more from experience in their classroom, but both of it goes together. That makes them the best qualified person when it comes to designing scaffolding. But according to OSHA, don't have to have an engineer until you get to greater than 125 feet, which is way up there. But again, here are all the different components. Base plate that I've mentioned several times. The vertical member, the post as it's labeled here, sits down on the base plate. The base plate will then attach with these 4 holes to a mud sill. Normally the mud sill is going to be dimensional lumber. I actually prefer mud sills that are 4x4s that are wafered together between 3/4 inch plywood, and that makes a good solid mud sill. In cross bracing, diagonal bracing, this shows the ladder access, which is important for every scaffold. You got to have good access. These diagrams off to the side here show the different hardware and the types of connections that are involved with a tube and coupler design. Guardrail system with toe boards, so on. In best practice, all elevated work platforms are engineered, and you follow a temporary structures and construction devices policy procedure within your company. This is a pole design supported scaffold. Now here you're required to have an engineer at 60 feet, which is still, it's a ridiculous allowance. Best practice, all scaffolds should be signed off on by a PE, designed and signed off on by a professional engineer. But a pole design is basically a stick-built design using different types of lumber, dimensional lumber, ranging from 2x6s all the way up to maybe 6x6s or 8x8s for your posts. Subpart L in the OSHA regulations, Appendix A, provides more guidelines for pole design scaffolds. Suspended scaffolds. Often you'll see these more for maintenance use, window washing, painting, tuck pointing, those types of operations. Suspension ropes that are used to suspend the scaffold basket must support 6 times the intended load. I mentioned this specifically because that's different than the 4 times the intended load that I mentioned before. And these are different types of scaffolds. They are hanging from supports. And a typical support system that you might see with a suspended scaffold is what we have over here. You'll have a support structure, a support frame structure up on top of the building with counterweights that will support the weight of the scaffold as it's raised and lowered along the side of the structure. Pump jack scaffolds can be very useful. You probably don't see these a lot in commercial construction, maybe more residential construction. A lot of brickwork will involve a pump jack scaffold. The pump jack scaffold system is designed so that it climbs up and down the support structure. Over here we have our support posts. The pump jack mechanism is on that support post, and this gentleman with his foot can pump that lever and cause the scaffold to climb the post. It's a climbing scaffold, if you will. Here are some other examples of this type of scaffold. Ladder jack scaffolds do not use. OSHA allows the use up to 20 feet. I think it's ridiculous. It's not safe. Find a different method. Just because it's legal doesn't mean it's safe. Another thing on this one, where the hell is he tied off to? He's using what we call a vertical lifeline. We didn't talk about vertical lifelines when we talked about fall protection, but this is a vertical lifeline. It's a piece of rope. He's got a rope grab on it. I think we did talk about rope grabs, but he's got a rope grab on it. And look at where his rope grab is. Look at how much slack is below the platform. This guy is probably going to be severely injured if he falls, even if he doesn't hit the ground. But he's going to fall 6 feet, 4 feet. He's going to free fall at least 10 feet before his personal fall arrest system does anything to stop his fall, because of the way it's set up here. Not a good setup at all. But again, even though OSHA allows this, it's not a good system. It's not a safe system. Same for this. This is a diagram from the OSHA manual. Sawhorses, stack them up to 10 feet high, or 2 tiers. Should not be allowed. It's a good example of some of the, what I would call, silly and dangerous practices permitted by OSHA. It's a good example of how OSHA is just the minimum. And companies that just meet those minimum requirements every day, they get people hurt. They get people hurt on horse scaffolds. They get people hurt on ladder jack scaffolds. Rolling mobile scaffolds, very useful tool. Some things to pay attention to. These are scaffolds that are on rolling casters. They roll around. The casters have to be locked when the work is taking place off of that work platform. They can be moved with workers on the platform, but they can only be moved with workers on the platform if certain precautions are taken. You have to be careful around edges and obstructions that might cause these things to tip over. That is one of the deficiencies, especially when you get up to multiple tiers like this. They can tip over fairly easily. If it's an uneven surface, if there are obstructions, if there's a drop-off that the scaffold could roll off of, that could cause a tip over. Now, there's no specific regulation limiting rolling mobile scaffolds to 2 tiers, but I think the best practice is a 2-tier maximum because of their instability. I really prefer the 1-tier setup like we have here and here, but if you need to go to 2 tiers, that can be acceptable as long as precautions are taken. One of the precautions I would want to see if we were going to more than 1 tier you would want some outrigger stabilizer type supports like we have here. This is not, these aren't sitting on single casters. These are sitting on multiple casters with an outrigger support design. That's going to help prevent tip over with this type of scaffold. We also see the same type of caster design or support design over here in this scaffold. Another thing that I would like to see if these scaffolds are being used, the rolling mobile scaffolds, handrails installed at all heights. Again, the OSHA regulation says 10 feet. Legally, this guy does not need to have a handrail. But if he falls off of there backwards and he hits his head, he's going to get hurt. The worst fall injury that I've ever had to work with was a worker who fell 4 feet off of a rolling mobile scaffold, and he hit his head on a stripping cart. He ended up in intensive care for 3 weeks, and he ended up with permanent brain damage. He was only 4 feet off the ground. It's not how far you fall, it's how you fall and what you land on, and a lot of other variables involved. These scaffolds are designed for handrails, for guardrails. Go ahead and install them. Doesn't make any sense not to use them. It provides another degree of safety, and it doesn't cost any more. It doesn't take any more time. It doesn't affect production. Go ahead and put the handrails up. If the handrails aren't being installed, it usually amounts to somebody's being lazy. They don't want to take the time to put the handrails up. It's not about the OSHA regulations. It's about protecting workers, preventing injury, making the company money. So if you end up in a position working for a company where rolling mobile scaffolds are used, I would encourage you to insist on handrails always being installed on this type of scaffold. All right, I'm going to go ahead and end this video here. When we come back, we're going to look at a lot of pictures of scaffolds, and we're going to do some hazard recognition exercises.